I will be conducting this stream mainly for those who were not able to attend the previous class due to we shifted the platform on MS Teams. So this would be based on this stream would be based on mostly the time and space complexity and some other prerequisites for beginning competitive programming. Like you need to know a few things like what are the different types of errors that you face and how to remove those errors and the basic things which you need to begin competitive programming. So we will cover these things, and for vectors we will have another stream maybe tonight. So let us begin now. Okay, so for starting, I will tell you what is the basic need of time complexity. Like why we need time complexity is that when you submit your code on any online platform like HackerRank, HackerEarth, or CodeForces, AdCoder, or somewhere else, then then those platforms have an online judge which check your code against a number of test cases, and it depends whether whether your program runs correctly on those test cases or not. मतलब अगर वो टेस्ट केसेस पे सही आंसर दे दिया तो फिर वो कंसिडर होगा करेक्ट आंसर में. लेकिन another thing which is also considered by those platforms is that they have a time limit, like your code should run in 1 second. They have a fixed time limit, 1 second, 2 second, or something like that generally. So the need is that generally the time limit of you can say on platforms like HackerRank, CodeForces, or AdCoder, etc. time limit for running your code is, you can say, 1 second, 1 or 2 seconds. So both are equivalent, means the thing will remain same. You will need something to measure your efficiency of code, you can say, whether your code is efficient enough to pass this time limit or not. So the basic need is you need to find out, okay, whether my code is efficient enough or not. So how to find out your efficiency, so we will discuss that today. Okay, so first one term I want to introduce is big O. Big O, it is represented by just the capital letter O, nothing to be remembered like that. So what it does is it just represents upper bound of a function. It represents upper bound of a function. So the thing is that if you want to study this in detail, then you will study in your maybe theory classes, but in competitive programming, just you need to know how to measure the complexity of your code. What is the time complexity, space complexity of your code in terms of big O. You just need to know that. Baki, I will tell you that what is the definition of that, but you do not need it much. So if you have a function, let us say if you have a function f of x, then then consider another function g of x such that f of x can be written as it is less than equals to some constant multiplied by g of x for all values of x greater than equal to some x naught. This is some, you can say, which is a definition of this particular big O. Okay, so you do not need to remember such things, but I am just telling for your information. We will discuss some examples, so this thing will become much more clear to you. So for an example, let us discuss this. That if you have a function, if f of x, or we will consider generally f of n. So if f of n is, let us say, n minus 2. So if it is n minus 2, can you write it like this? F of n is less than equals to some constant, let us say 4, or anything you can take, let us say it is 8, multiplied by some value, like you can take n. Okay, so I can say fn is less than equals to 8 into gn, where gn is nothing but n. So by definition we can say that f of n can be written as big O of n. The main thing is you do not need to do such calculations in general codes, but just you see that it is an, as it is a function like n minus 2 or a polynomial function, then you say the highest degree term is itself the big O. Like if you have something like, if you have f of n as something like, let us say 3n square plus, let us say 3n square plus 5n plus 8. So what is the highest degree term? It is n square. So the time complexity would be big O of n square. Just you need to remember this. The highest term or the most contributing term would be the highest term, you can say highest degree term. So it would be having a time complexity of O of n square. You need to remember this thing only. So this was just for your information. I gave you this definition, but you need not remember this. Okay. So now this was the thing that what is big O. Now let us see with an example of program how to find the big O of a code. So let us say you all know what is an array. Array is used to store similar data types, a large number of variables of similar data type we can store in a single variable. You can say we use array for that. So consider we have an array, consider an array A of size n, and I run this code. Let us say for int I equals to 0, I less than n, I plus plus, and I print all the elements of the array. See out ai. So I am, by ai I mean ith element of the array. So I am printing all the elements one by one. So can you find how many times each of the statement will run? Like you can see, this small program has three or four statements. Like first is this statement, one is this statement, one is this statement, and this is another statement. So if you see, I told that in you also know, you might be knowing that this is the initialization syntax. Initializing means this will run only at the starting, only one time this statement would be run. So it will run only one time. So I can say I equal to 0 will run only one time, and I less than n, how many times this condition would be checked. So if you see, if you take n equal to 5, so it would be checked 5 times, you can say. For 0, I equal to 0, I equal to 1, I equal to 2, and in this so on, maybe n or n plus 1 times, you can say n plus 1 times. So approximately it will run. If you try for any value of n, you can check it that this statement would be running, would be checking, we will be checking this condition n plus 1 times. So I plus n will be run n plus 1 times. So can you say how many times you can just think how many times this will run? Pause the video and think for a while how, for each statement how many times these statements will run. So I will tell you, I less than n is running how many times? N plus 1 times, and I plus plus will be running n times. So in this way, if you see how many times this statement will be executed, so it will also run. See out a of I will be run n times. If you are not understanding this, how this n times is coming, so you can check it for any value of n. You can take n equal to 5, n equal to 6, and try. You can try how many times this statement is running. By you can dry run on your paper or somewhere, you know? So you can try it. So let us discuss one more example. One more thing. In this, why I am discussing this is I need to find the time complexity of this code, or you can say efficiency of this code. So can you tell what would be the time complexity? So if you try, then the time complexity means you need to find out what would be the number of steps your program is running. So like here we are running 1 plus n plus 1. For each statement I am adding these. So n plus 1 plus n plus n. So if you sum this, you will get something like 3n plus 2 equal to 3n plus 2. But always, you know, this exact number is not required. I am just telling to explain you, but you need to write only the big O. If you can calculate the big O, then there is no need of this exact expression in general. So this is equivalent to big O of n. Why big O of n? I told you, in polynomial the highest degree term is n, so we can say it is big O of n. the constants do not matter whether it is 3 and 5 and 7 and 100 and or whatever. Only this highest degree term is the big O. Okay, so this is important. You just always in your code you will need to find out what is the value of the big O. If you find this big O, then you can find out your efficiency of your code. So this is the thing which is required in general. And one thing is that, okay, we will discuss some more examples so that this thing becomes clear to you. So one thing is, like, if what I do is, if I just make a small change in this program, if I am doing something like I am putting a if condition, if a of I equal to some value, let us say I have a value into variable, I have a variable value, and I compare all the values one by one of the array and I check whether it is equal to ai or not. Okay, if I do this thing, then what would be the time complexity of this code? Okay, let us say that I have another variable bool. I'm searching in the array for a value. Okay, so I take a variable bool found equal to false, and if I find that element, I will do found equals to true, and I will break from the loop. So if I tell you that find out the time complexity of this code, so I was telling that if you find out the time complexity of this code, you might have a confusion like what should be the how we consider the if statement, because this if statement depends on the value of the array. If the array contains this value, then it will break only, this for loop will run only one step, and if the array does not contain this value, then in the worst case this for loop will never break, so it will run in the same in the previous case. The almost these statements will run n times, and the time complexity will be O of n. So which case should we consider, the worst case or the best case? So this thing you should remember is, while finding the time complexity, we always consider the worst case. Consider the worst case scenario in finding time complexity of a code. So this is an important note here, that so now if you consider the worst case, so what should be the worst case here? Worst case means you can say that the how much the upper bound of your code should be, means we can say, like, if the array, consider the case like if your value is some 8 and your array does not contain 8 anywhere, so this for loop or this code will run n times in the worst case. So I mean that this for each statement also you can see, but we need to only find the upper bound, so you do not need to find this exact 3n plus 2 or this number. But if you see how many times this statement, if a statement will be executed, or this I plus plus statement will be executed, then you will get n times, approximately n times. You need to always approximate things while finding time complexity. You do not need the exact number. I am repeating this once again. So approximately your time complexity would be n times, O of n, you can say. Time complexity would be O of n. So this was another example, and after this, if you have a concept in your mind that okay, I know how to find a time complexity of code, so I will give you one more example. Like, if you have a simple code like this, int, if you say like int a equals to 2 into b and cout b, and you have some int b, some variable of b if you have, so what should be the time complexity of this code? So you can see that it is executing only 1 or 2 times, like there are 3 statements, 1, 2, 3. So whenever there are only constant number of steps or constant number of execution or constant number of statements, you can say, so in such a case you can say the time complexity is constant, like it is not depending on any variable like n times or 2n times or like that. So in such a cases the time complexity is said to be O of 1, or you can say a constant time complexity, constant. Okay. And after this you can also consider some other examples, like we can have, if I have something like this, for int I equals to 0, I less than n, I plus plus, and inside I have another loop for int j equal to 0, j less than n, and j, or you can say j less than I and j plus plus. So if you try to find out the time complexity of this code, just try to think, and if I have something here, something I have written here, you can say like something like cout 1 or anything, it can be any statement. Okay. there can be multiple statements also, but you need to find out the time complexity of this whole code. So by time complexity I mean, in the worst case, how many statements you will run, approximation of that. You do not need to find the exact thing. So but still, for explaining, I can show you how the exact things are calculated. Like I will say that for I equal to 0, the inner loop, how many times it will run. Just try to think, inner loop will run how many times. You can say 0 times. This statement will run 0 times, because 0 is less than 0 na. When I will be 0, you can say this condition will become false, so it will not enter the loop. So this inner loop will run 0 times. If you consider I equals to 1, the inner loop will run only 1 times, because 0 is less than 1, it will enter the loop. But after that, j will be plus plus, so 0 will become 1, and this 1 less than 1 will be false. So for I equals to 1, this inner loop will run only 1 time. Similarly, if you say for I equals to 2, if I becomes 2, because I is incrementing by 1 at every step. So when I will become 2, how many times this inner loop will run? So j will be 0, 0 is less than 2, yeah, 0 is less than 2, so it will run. Again again j will increase by 1, so it will become 1. 1 is less than 2, yes, it is less than 2. Again it will increase by 1. 2 is less than 2, no, it will break out of the loop, because the condition is false. So it will run 2 times, the inner loop will run 2 times. If you do this for some steps, so you will find a pattern like for I equals to n, or I equals to n minus 1, you can say the inner loop will run n minus 1 times. So it is something like why I am telling about n minus 1, because this outer loop will run only n minus 1 times. So the total number of steps, if you find total steps, I can say total steps would be, if you sum out these 0 plus 1 plus 2 plus n, so if I sum out how many times the steps would be running, so 1 plus 2 plus so on, it will be going up to n minus 1. If you sum this out, you will get something like quadratic equation. If you sum this out, I think you will be getting, it is sum of n minus 1 natural number, so it would be n into n minus 1 by 2. So approximately this thing. Exact thing may vary by a little bit amount, but the approximation would be this only. And if you expand this, you will find that it is a quadratic equation. It is a quadratic polynomial basically. So you can say the highest degree term is n square, so the time complexity would be n square. I am just explaining this, so I am finding this exact term. Otherwise, you just need to find whether it is over n square, n cube, and root n, log n, or whatever function is this. You need to find out that function, big O of that function. What is the big O value? So now I will give you a problem. You can when you are trying this, you can pause the video and check and try to find out by your own what should be the time complexity of this code. So this is your code, and inside this I am writing any statement. It can be anything, like it can be cout ai or whatever, or it can be anything like sum equal to sum plus I or whatever. Any statement can be here inside, but you need to find how many times this will be executed, how many times it will enter the loop, or you can say what is the time complexity of this code. You need to find out. So you can pause the video and try it by yourself, and then I will discuss this. So if you think over it, again try to do the same thing like we did in the previous case. Just try to check for I equals to 1, how many times how many times the loop will run. So we can check for I equals to 1, yeah, the loop will run. Then what will be the next value of I? Each step, now I is multiplied by 2. Here it is not written I plus plus, but it is multiplied by 2 at every step. So first I will be 1, then next step it will become 2, then 4, then it will be like this. I will be 2, then it will multiply by 2, 4, multiply by 2 again, 8, multiply by 2 again, 16, and so on. How many times? I don't know, but it will stop until it becomes greater than n. So it will go on, and when it will stop, so I don't know how many. Let us assume that it breaks out of loop in k steps. I need to basically find out this value of k, so I don't know, so I can assume it. Let us say k steps. So if you think over it, then after k steps, what would be the value of I? Because after every step it is multiplied by 2, so after k steps it would be 2 multiplied by k, you can say, sorry, 2 to the power k, 2 to the power k, because it will be multiplied by 2 k times. So 2 to the power k multiplied by, you can say, 1 multiplied by 2 to the power k, because initial value of I is 1, so it will be multiplied by 2 k times, and this, it will break out of the loop when this thing will become greater than n, because if it is less than equal to, then it will again enter the loop. I need to find when it breaks out of the loop. So for breaking, it should be greater than n. This condition should be false for breaking out of the loop, so it should be greater than. And if you solve this, you can directly say 2 to the power k is greater than n, and if you solve this, it would be, k would be less than, or you can say approximately, we need to find out the approximate value of k. So you can say the k would be approximately log n base 2, log n base 2. This is approximation. It may be something, a very little value greater than this or small than this, but we need to just approximate things here. So why it is, because by definition of logarithm, you know that logarithm is basically what is the power raised to a number. So you will find that k will be approximately equals to log n base 2. So the time complexity of the code is O of log n. If you face any doubt, if you have some confusion, you can always comment on this video, so I will be trying to answer it. And you can always discuss in the next class, that if you face any difficulty, you can always discuss in the next class. But I would say ki try to solve these things in pen and paper, and you will get almost all the things. So after this, we can have one more example for time complexity, so that things become much clear to you. So let us say we have this particular code for int I equals to 1, I less than equals to n, I plus plus, and inside this, let us say we have something like, for int I equals to, okay, let us say we have something like this, I equals to n, I greater than 0, and I minus minus, means I am now decrementing I by 1 every step. Okay, and inside this we can have something which goes up to, you can say, I less than, and I less than, oh sorry, here we have j, inside the inner loop we have j equal to 0, j less than I, and j plus equals to 2. Okay, so you need to find out the time complexity of this particular code. So I would say again, pause the video, try it by yourself. Inside this we have some code. You can assume that inside this we have some code. It can be anything, it doesn't matter, but the time complexity of this code would be almost same. So it can be something like this. It will be something constant steps only here, like cout 1 or something, and some more steps can be here. So you need to find out the time complexity. You can pause the video and try it by yourself. Then afterwards you can see the solution and match your answer. So again we analyze this. So for I equals to n, the inner loop will execute how many times? If you find out, so what is happening inside the inner loop is, it is only going to the even number of variables, like 0, then 2, then 4, because it is incrementing. Achha, j plus equal to 2 is same as j equals to j plus 2. This you should know. This is the syntax of C++. You can write short, this is called shorthand syntax, means j equal to j plus 2 can be written as j plus equal to 2 also in C++. This is the short syntax, you can say. So if you don't understand this, you can consider it as like that only, j equal to j plus 2. There is no problem in that. So if you find out, so for I equals to n, this inner loop will execute how many times? It will go only even terms, like j equal to 0, then 2, then 4, because it is increasing by 2 at every step. How many times it will go? It will execute up to n by 2 times, you can say. It will execute n by 2 times. When I equals to n, then it will execute approximately n by 2 times. Now when now after this I n will I will become n minus 1, because I is decreasing by 1 at every step. I minus minus means I equal to I minus 1, or you can say I is decreasing by 1 at every step, at the end of every step. So now I will become n minus 1. So how many times now the inner loop will execute? You need to find out that. So if you find out, so again it will go to only even terms only, even terms with only half of the terms it will go, 0, 2, 4, 6, like in this way, in this fashion, and up to n minus 1, you can say. So it will execute n minus 1 by 2 times. N minus 1, this whole thing divided by 2, you can say. And if you do this for the similar thing for I equals to n minus 2, so this inner loop will execute how many times? N minus 2 by 2 times, and so on. This thing will be executing so on until I equals to 1, you can say, up to I equals to 1, or I equals, it will break out at I equal to 0. So for I equals to 1 or 0, the inner loop will execute one time approximately. So basically, if you need to find the time complexity, then just you need to sum out how many times this inner loop is executing. You might have a question, why not summing out this, how many times this statement is executing, how many times this statement? Because these are always be less. Like this statement will be executing only n minus 1 time, so it is always less than what this would be executing the most number of times. And the statement which is executing the most number of times is only significant to us, is only important to us for calculate time complexity. So this statement is the critical statement, you can say, which is executing the most number of times. So we need to find out how many times this will execute. So the time complexity would be n by 2 plus n minus 1 by 2 plus n minus 2 by 2, and so on. So again, if you try to sum it, you can take 1 by 2 common, and you will get something like n plus n minus 1 plus n minus 2 and something like that. So again, it would be same as the previous case, like it would be O of big O of n square. If you feel any ambiguity or something, then you can always write in the comment. If you feel any confusion here or something. Okay, so I think this is enough to get an idea of what time complexity is and how to calculate the time complexity of any code. So one homework question for you can say, you need to find out this time complexity of this code. I am just writing it in here. So it is something like, for I equals 0, I less than equals to n, and at every step you can say, let me do it I plus plus only, and here I am checking whether I square is less than n. You need to find out the time complexity of this statement. It can be anything inside this for loop. Find out this the time complexity of this statement, or I mean that this whole code, you need to find out the time complexity. So this is one thing which would, now using this time complexity of code, you need to find out whether it would be able to pass the time limit of 1 second or not. This is very important. One thing you need to always remember is, in 1 second, 10 to the power 7 or 10 to the power 8, or you can say 10 to the power 7 to 10 to the power 8 operations can be performed. This you should remember. This is very important thing. So suppose in question, suppose you have something like this now, that in question you are given that n equals to, suppose n is less than equals to 10 to the power 5. Okay, so if in question you are given n is less than equals to 10 to the power 5, then find the and I have two three parts for this question, you can say. Suppose you have written code with time complexity big O of n square. So my question is that, will this code be fast enough to pass this time limit of 1 second? Means will your code take more than 1 second, or it will be passing in this time limit of 1 second? My question is this: you need to find whether your code will pass time limit of 1 second. Similarly, if your time complexity, first let us see how we'll calculate this. So the thing is simple. If you have a time complexity of n square, so if n is we always consider the worst case I told you earlier. So if n is less than equal to 10 to the power 5, in the worst case it is equal to 10 to the power 5. Okay, so in the worst case it is equal to 10 to the power 5, and now what will be the square of this 10 to the power 5? It would be 10 to the power 10, right? So you can say, in worst case, code takes, I am discussing the solution of first one. Okay? Or in the worst case, code takes, you can say, 10 to the power 10 operations to perform, but this is greater than that. I needed to tell you that if, because this is greater than 10 to the power 7 or 10 to the power 8, so it is very slow, so it cannot pass a time limit of 1 second, so you will get an error. So your code will not be accepted, you can say. Your code will not be considered as correct answer. But if you write for the same n less than equal to 10 to the power 5, if you write a code with time complexity, I am not telling what the code is, but it can be any code with this time complexity of big O of n log n. So now you need to find whether your code will be able to pass time limit of 1 second or not. So if you find out what would be the value of n log n in the worst case, so n log n in the worst case, in worst case only I will tell, because what I told you earlier, you need to always consider the worst case scenario. In worst case, n log n equal to 10 to the power 5 multiplied by 10 to the power 5 log of 10 to the power 5 base 2. Always we will consider the log base 2 only generally in competitive programming. So it would be something, I'm not getting the exact value, but it should be less than equals to 10 to the power. If you calculate it by calculator or something, or you approximate it, then you will get it is less than equals to 10 to the power 7 or 8. So yeah, it will be passing the time limits. There will be no problem in that. So it will pass the time limit of 1 second. So this was the concept which we needed to tell whether our code is able to pass the time limit or not. This is the thing we should know. Means for any code, you know how to calculate the time complexity, and you also know that in 1 second only 10 to the power 7 or 10 to the power 8 operations can be performed. So using these two things, you can always find whether your code will be able to pass the time limit or not. So this is important, because before writing any code, you always have a code structure in your mind, so you can calculate the time complexity of your code, and if your time complexity is correct, or it is fast enough, or it is efficient enough to pass this time limit of 1 second, then only you will write that, you will utilize your time to write that code. But okay, if while thinking only, if you get okay, my time complexity is very slow, so it will not pass the time limit, then why you will waste your time in writing the code? This is the important part. This is where you will save your much of the time in writing the code. So this is very important. Again, I will tell, if you have any doubt, any confusion, try to clear in the comments, or you can always write it down somewhere, and you can discuss in your either in your Telegram group or in the next class you can discuss. So okay, so this was up till now we have discussed time complexity and how to find whether our code is fast enough or not. Now we will discuss some common errors in online platforms, common errors which you will face while solving problems on online platforms like HackerRank or Codeforces, etc., or at Coder like this. So we will discuss some of them, so which are you can say, one is compile time error or compile error. It is also in short formed as CE. So it is simple. You also always know that if I write a code in my compiler, and like if I suppose if I remove this semicolon, I forgot to put semicolon, so if I compile this, at compilation only I will get an error. So such error which are indicated by the compiler itself, compilation is failed in that cases, or due to some invalid syntax of the language or something like that, due to such reasons you will get a compile time error. So they are very easy to remove, so we will not discuss much of them. So they are indicated by the compiler itself with the line number. The compiler nowadays also tell you the line number in which error has occurred, in which there is error. So these error are not much problem causing, but one is wrong answer. This will trouble you if you are a beginner. Wrong answer in online platforms. So you may think that my code is correct, why I am getting a wrong answer here. So the thing is that if the program or if the question tells you to print yes, like if the question tells you to print yes, and if you print it like that, I can say yes is not equal to yes. You can say both are equal, but this is small e and s and this is capital E and s. So if you see out this thing, but in the HackerRank it was written to print capital YES, then you will get a wrong answer. So how to prevent this? To prevent this, I would say read the input and output format in the question carefully. I would say read it 2 or 3 times in the question very carefully. And if it is written to print capital YES, then print capital only. If it is written to print like this, then print this only. So, and similarly, if it is written to print a backslash n or to print a new line or blank line, then only print a blank line. Such things you should remember. Like when you are solving question, always read the input and output format. If you feel, then I can always give you an example of what is input output format. So you can take any of the question and you will always find input output format if you go to problem solving. And let us say if I pick any question, so you will always get a you can say you will always get some input output format in your question. So like this question has an input output format. The input format is first line contains integer and output format is something constraints are given. So these constraints are helpful to calculate the time complexity of your code and find out whether it will pass in 1 second or not. And output format is only return the integer sum. So you need not return anything extra. If you return something extra, if you print something extra on the screen, then you may get some wrong answer error. So always try to read this input and output format multiple times carefully. So this is how to prevent wrong answer. And still if you are getting a wrong answer, then it means that your code is wrong. Somewhere you are doing something wrong in your code, or you are missing some corner case, or you are forgetting some small case where your code may be wrong. Okay, so otherwise one more error is time limit exceeded, which we have discussed almost. You can say it is also called TLE. TLE means time limit exceeded. So we discussed it earlier. The time limit is generally, I told you earlier also, time limit is generally 1 second. And if your code is slow, you will get this error. And if your code is slow, then to pass this time limit, you will get this error. So you will get this error in only these cases. And still, if you think your code is fast, then also you are getting TLE. Then one thing you can try is, there is a syntax of fast input and output IO. So for this I would say ki you can also use fast input output with cin and cout. In previous class somebody asked me that whether we should use printf or scanf or cin cout for input output. So I told that both are equivalent. If you use fast input output, then you can also use cin cout. And otherwise if you do not use fast input output, what is fast input output, I will tell you in 1 minute. And if you do not use fast input output, then printf is faster, printf and scanf are faster. But using fast input output with cin cout, it is almost equivalent to printf scanf. So what is the fast input output is, there is syntax like this: int main. Inside int main, whenever you write your code, just write this line above. At the topmost line, you can write inside your int main, just write like this: IO is base sync with stdio false. It is something like this: sync with stdio false. And below cin.tie null, cout.tie null. If you are a beginner, you need not remember this much. You can always copy paste it from somewhere and you will remember this after writing some number of programs. So you can try to remember it, but there is no need for now. But always remember that when you get time limit exceeded, you can always use this, because there might be cases when your code is fast, then also you are getting time limit exceeded, TLE. So you use this statement, and after that now write your whatever code is there. Means this should be at the top of your int main, inside your int main at the top. So now you may not get TLE, because now if you do cout and cin, it will work much faster, because now buffers are not cleared, you can say. So due to this will make your cin and cout work much faster than before. So now you may clear the time limit of 1 second or whatever it is given in the question. Like the time limit is always given in the problems. If it is not given, then you must consider the time limit as 1 second. Okay, if nothing is given in question, then time limit is generally 1 second for any platform. So this is, and all your code should be before after this, all your code after this, so it works like this. And one more thing is runtime error. After time limit exceeded, we will see what is runtime error. So runtime error is also another error, like it is you if you will face this when something like it can be like if you are accessing an unknown or an, you can say, invalid element of array, like if you have an array of size 100 and if you are accessing the 1000 element. So obviously if the array is small and it contains only 100 element, so it will give an error when you access the 1000th element. So if you are accessing an invalid element of an array, like you can always try this in your compiler and try running it. If you have an array of size 100 and if you print cout arr 100, so it will give an error. Why? Because counting starts with 0, so there are only 100 element from 0 to 99 and you are printing the 100th element. Or you can also try this 1000. So the array contains only 100 elements, and if you are printing the 1000th element, then it is an invalid element because there are only 100 elements, so you cannot do this. So it will cause a runtime error. Also, if you print like this, if you access the -1 index like cout arr -1, then also you will get a runtime error because there is no element called -1 in C++. 0 is the first index of element, 1 is for the second element in this way, but there is no element called -1. There is no index called -1, so you will get an error. So such error is called runtime because you face it when running your program. After running only you will get that error, so it is called runtime error. Before compilation or during compilation you would not get this error generally. And also it happens when you divide by 0, like if you do cout a by 0. So in mathematics you see a by 0 is infinity, but in C++ it will give an error. So try it whenever you are doing division. Always remember that you should not divide by 0, or if you are dividing by variable like you are dividing by x, so you will always check that x is not equal to 0 before dividing. If x is not equal to 0, then only you will divide this thing. So always remember these things. One more thing is overflow. Overflow is very important and you should know this, that how to prevent this and what is overflow. So one thing you can try is int a equals to 10 to the power, you can take 9, I will take 10 to the power something like this, 1 2 3 4 5 6 7 8 9 or something like this. And one is b is also having some value like this. So if you add these two, or okay, if you multiply these two, let us try to do in our program. If I do this, like I have two variables, a is this, b is this, a equal to 10 to the power 9, b is 10 to the power 9, and if I do int answer equal to a into b, suppose in the question I need to find the product of these two. So if I do this and if I cout the value and if I run this program, let us see what should we get. 10 to the power 9 multiplied by 10 to the power 9 should be 10 to the power 18. Easy, but let us see what is the output. So if you see the output, you will get something surprising. If you are a beginner, it is -1488, something like that. You can observe that it is very unfortunate that you are getting such kind of thing, but you should understand why this is happening. So the output of this would be, I will leave this code inside the Google Doc. I will copy this code, always run in your compiler and try this. So if you will run this code, the output is some negative number, something like 148 or something like that, some negative number. I am not writing the exact value, but some, okay, so something like this you will get. It is an wrong answer, you can say. So if you are getting a wrong answer in your hackering or somewhere, so this can also be one reason. So why this is happening? So this is an overflow because integer, I told you in the first class itself that int data type or integer data type can store integers only up to 10 to the power 9, approximately 10 to the power 9 approx. Numbers greater than this cannot be stored in an int variable, okay, because integer have a small range. So for bigger integers up to 10 to the power 18, you will use long data type, use long variables. So what should I do? So you can say that you can store the answer in a long variable, long answer equal to a into b. But if you do this, still you will find that error occurs, overflow occurs, still you will find some negative value. So you will see that this is the output you get, again minus 14866, that again that invalid garbage value, you can say invalid value. So why this is happening? You have taken a long variable, still this is happening. So always remember that overflow means if you are multiplying an integer by an integer, it doesn't matter where you are storing your answer, but during the multiplication itself you should make one of the variable is long. Like I will also copy this code, that if you do this thing, that you store your answer in a long variable, still wrong answer you will get. It is still you will get something output like this, the same output you will get, no effect on the output, okay, still overflow is occurring. But if you do like this, if you do like this, that while multiplying you convert one variable into long, during the multiplication itself you convert this into long. This is a conversion syntax in C++. You can write in bracket in which data type you want to convert, and then that will convert like this. If I write in bracket long, then it will convert this a into long, and after converting it to long, then only it will multiply this thing with b, and then only it will store it into answer. So if you do this, now it is correct, So always you need to remember, whenever you are multiplying or adding, that time you need to convert, and also along with that, also the answer should be stored in a long variable. Both things should be there to get a correct answer, to prevent overflow, you can say. So if I do like this, then you see the output would be correct. It should be 10 to the power 18. So yeah, you can see on your screen it is 10 to the power 18 and correct output is now here. But you will feel that this is very complicated syntax. Again and again I need to write bracket this thing. So I will tell one more easier syntax. So better, one more method is, I would say, one more method is always use long variables. Try to use long variables. So what I am telling is, instead of int a and int b, you can take long a and long b. So what is the problem in that? So but you should always remember that using long will take more memory, will use more memory. So long, if I take long a and long b, then it will take more memory. So it would be something like this. If I take both as long, then if I print, like now I do not need to convert it into long, it is already a long a is already a long variable, so I need to just print it, and you will see that if you print it, then you will get the correct value. Means again now we will get the correct value. You can try in your computer, you will always get the correct value here. This is also correct. So this is how do you prevent the overflows. Okay, so this is always you should remember. And one more thing is, like in time complexity we discussed the time complexity of various codes. So also you should remember one more thing in that is, in general you should remember some basic time complexities. In general, some basic the comparison of various functions, like in general big O of 1 is the smallest time complexity, greater than it is log n, and greater than it is O of root n, and greater than it is O of n, and greater than it is O of, you can say, n log n. So this will help you in writing an efficient code. Suppose you are writing a root n code, so you will always think, can I write a log n code and make it more faster? If you can, then you will try to write a log n code, O of log n code. So this will help you remember in the comparison of various functions. So which time complexity code you should write. So it is, if it is n square, then it is more greater than that, and if it is O of n cube, then it is more greater than that, and so on. And if you can have O of n to the power 100, then also it is much better than O of 2 to the power n. People say like this. Why? Because we are always comparing these values for a very large value of n. Let's say n is 10 to the power 5, 10 to the power 7 or some large value. So for a very large value, 2 to the power n is very worst, very large. So it is very slow. It is taking more number of operations. So anyways, you can say that O of n to the power 100 is much better than O of 2 to the power n. Why? Because you can find out the values of these two functions for very large value of n. Let us say n equals to 10 to the power 5 or something like that. So this is a general comparison of functions. And other than this, there are some more basic things which you should remember, like never compare floating point numbers with equal to, okay, with equal to sign. Why is it so? So you can try this program for this, like okay, you can, there are some programs for that, I do not remember exactly, but if you, there are some numbers like if you compare float a equals to 1.000001 and float b equals to something 1.00000000. So approximately these two are equal, but if you compare using this, if a equal to b, then print equal. Try running this program in your computer, so you will get that they are not equal maybe. So what I am telling is, generally in floating point problems you need to consider some of the numbers is equivalent, like these are approximately equal, so generally you will try to consider them equal. Why? This small difference will not matter much in most of the problems. So for this to work, equal to is not giving you correct answer, so you will never compare with floating point with equal to sign, because not only this case, but you will find that when this number are exactly equal also, then also there is some precision due to which they are not equal, they are not considered equal by C++. So you will for floating point means for decimal numbers like this, for fractional numbers, so you will never compare fractional number with equal to sign. So how will you compare them? Then you can, there is one method to compare it. You can take a constant value, const, float, epsilon, or any name you can give, and you can take it very small value, 0.0001, something like this. It is also, you can write it like this, 10 to the power minus 6, 1e minus 6. You can also write it, both are equivalent. And you can now compare like this. You have, suppose you want to compare two numbers a and b, so now you will compare like this. You will find out the absolute value of difference of these two, a and b, and whether this difference is less than epsilon or not. And this epsilon will depend on, this epsilon will be given in most of the questions. Or you can take it some value like this, 10 to the power minus 6 or minus 7, 10 to the power minus 7 or something like this. And if they are equal, then print equal, otherwise not. Then print equal, otherwise not equal. So these are some of the basic things which we wanted to discuss. So if you have any doubt, any question, any confusion in any of the topics, you can always comment, and always you can ask in the Telegram group also, or in the next class also you can ask. So till this we have discussed most of the basic things which you should know regarding time complexity is, and one more thing is space complexity. Let us cover that too. Space complexity, there is nothing much about space complexity, but it denotes the big O of how much space your program is taking, space taken by a program, variables and etc. So like if you declare an array of, let us say you declare an array of size 1000, so it is taking some 1000 into 4 or something like that number of bytes. If you declare array of size n, so you are using O of n space. Okay. And if you are declaring an array of size, you are declaring suppose 2-dimensional array, there are also 2-dimensional array like a matrix, you can say it has n rows and m columns. So if you declare like this, then it uses n into m cells or n into m space, big O of n into m space, like this. And one more thing is, you cannot declare an integer array of an integer global array. Global means outside the main function. If you declare an array outside the main function, it is called global variable. So if you declare an integer global array, you cannot declare integer global array of size greater than 10 to the power 6 or 7, 10 to the power 7 or 6. It depends on the compiler and online platforms, but some allow 10 to the power 7 or some allow 10 to the power 6. Depends on the online platform which you are using. Approximately I am telling this order. Okay. So these things you should remember. So whenever you're declaring array, so you should check its size should be something smaller or equal to this or this. Or for floating point array, the size may vary. For long array, this size may still very small, means it can allow only, because long takes more number of bytes than integer, so it may vary. So this I would end this stream now, and you can always watch this anytime, and if you have any doubt you can always ask. So bye.